Stop! We've heard quantum frameworks and recursive loops for 20 minutes, but not a single word about why this matters.
You've dismissed every question about costs, UI, and customer impact to lecture us about microservices?
We're not funding a PhD thesis. We need solutions that our team can implement and our users will notice. This feels like a solution in search of a problem.
Hi, I'm Alex. 3 months ago, I almost lost the biggest opportunity of my career. Today, I'm leading our company's most innovative project. The difference? Not what you might think. I'm a very brilliant software architect. I used to think my technical skills were enough. I thought my work spoke for itself. Then came the project that changed everything. What happened next surprised everyone, including me.
You have met Alex, a software architect. Alex writes code that machines understand perfectly, but humans? Not so much. His algorithms are poetry to engineers, but when presenting to stakeholders, it's all static. Watch what happens when brilliance meets human disconnect.
Our system leverages a heterogeneous polymorphic recursion pipeline, where functions perform recursive calls with varying type parameters to orchestrate heuristic-driven state transitions and deliver amortized O log n throughput across a distributed, mesh-oriented microservices fabric. We layer on hyper-threaded asynchronous I/O virtualization, e.g., Linux's I/O whirring, to decouple service latency and enable speculative, multi-threaded I/O pipelining. This combination ensures resource elasticity and drives sublinear, cross-cluster scaling, while minimizing algorithmic entropy.
Alex, could you simplify?
Let me finish explaining the back-end architecture. You need to grasp the architecture first. Perhaps I should re-explain the distributed microservices fabric. Our backend uses generic polymorphic service interfaces to build an extensible, heuristic-driven framework. Core algorithms rely on controlled recursive routines for decision flow, while Linux's I/O whirring enables non-blocking, multi-threaded I/O for high throughput. State transitions are managed via explicit state machine patterns, ensuring each microservice scales independently under load.
I haven't understood a word for the past 5 minutes.
Perhaps I should explain the back-end infrastructure again, since some of us aren't following.
About the user interface?
We'll get to UI after I finish explaining the critical path analysis matrix.
But how does this help our customers?
We'll get to that later. Now, about the microservices architecture.
Alex, stop!
Okay, I'll wrap it up. So, in summation, our future hinges on generic polymorphic service interfaces driving heuristic-guided recursion over balanced tree indexes, delivering true O log n performance, while Linux's I/O whirring powers non-blocking async I/O, and pragmatic debt management keeps our platform scalable. This is the future. The framework's elegance speaks for itself. Anyone serious about innovation would see its inevitability.
Stop! We've heard quantum frameworks and recursive loops for 20 minutes, but not a single word about why this matters. How does a polymorphic architecture solve our customers' complaints about slow load times? If you can't explain it in plain English, this project isn't viable.
Exactly. We're not funding a PhD thesis. We need solutions that our team can implement and our users will notice. This feels like a solution in search of a problem.
Let me save us all time. You've dismissed every question about costs, UI, and customer impact to lecture us about microservices? If you can't align your work with business priorities, we can't justify the budget.
And frankly, if we don't understand it, how will marketing explain it to customers? We're rejecting this. Come back with a proposal that starts with user needs, not nested algorithms.
Even if this O log n magic works, which I doubt, your timeline assumes 0 setbacks. You're talking 12 months and $1 million for something we can't even demo? We're not a R&D lab. Let's revisit when you have a prototype that does one thing well.
Brilliant code isn't enough if we can't understand its value.
Quantum-based algorithmic framework. Sounds like a buzzword salad.
We're allocating your team's resources to Maya's client-facing projects, effective immediately.
Brilliant code can't fix tone deafness, Alex. We're not just rejecting the proposal, we're sidelining you.
Innovation isn't enough. Without connection, even genius becomes noise. Sound familiar? Ever explain something brilliant only to get blank stares? You're not alone, and Alex isn't alone. Whether it's a teacher whose lessons don't land, a marketer staring down a rejected campaign deck, an engineer stuck in the crossfire of mixed messages on the job site, or even a street vendor whose snack pitch falls on deaf ears. All brilliant in their craft, all missing the same vital piece. Here's the question no one asks. Why does hard work fail? In this case, what really caused Alex's brilliant work to fail? Let's break down the 4 critical soft skill failures we just witnessed. Presentation skills. First, a presentation delivery failure. Alex relied on complex slides and jargon instead of clear, compelling storytelling. Communication skills. Second, a communication breakdown. He used technical jargon instead of clear language that his audience could understand. Emotional intelligence. Third, an emotional intelligence gap. He missed critical social cues, dismissed concerns, and failed to build trust with his stakeholders. Audience awareness. And finally, an audience awareness failure. He focused on technical details instead of connecting his work to business value and user benefits. These aren't just presentation mistakes, they're career limitations. In part 3, you'll see exactly how Alex learned to transform each of these weaknesses into his greatest professional strengths. And more importantly, you'll get the exact framework Alex used, applicable to any situation where your words need to land. These aren't just presentation techniques, they're universal communication principles that work in boardrooms, classrooms, living rooms, and everywhere in between.